Will this expression converge for certain values of x? To answer this question, we first need to clarify what kind of expression we are dealing with. This operation is called tetration, also known as a power tower. Tetration means repeated exponentiation. You take x to the power of x, to the power of x, and so on, for a total of n levels. For example, take 2 to the power of 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 2. Even this relatively short tetration already evaluates to 2 raised to the power of 65,536, which is a number on the order of 10 to the power of about 19,700. That vastly exceeds the estimated number of atoms in the observable universe. There are several notations used for tetration. One common notation uses a left superscript. I personally prefer the arrow notation because it makes the hierarchy of operations very explicit. In this notation, one arrow represents exponentiation, 2 arrows represent tetration, and 3 arrows, yes, you heard that right, there's more, 3 arrows represent pentation. 4 arrows represent hexation, and the pattern of these so-called hyperoperations continues from there. Each additional arrow corresponds to a fundamentally new operation, growing far faster than the previous one. Tetration already grows much more rapidly than ordinary exponentiation, and yet, surprisingly, for certain values of x, an infinite power tower, the limit as the number of levels goes to infinity, can still converge to a finite number. Remarkably, it can be shown, going back to Euler, yes, this guy again, that this happens when x lies between e to the power of minus e and e to the power of 1 over e.